We're going to talk about trends in for atoms according to the shape of the periodic table. This question says, which atom has the greatest first ionization energy? Now, I'm just going to draw my little mini version of a periodic table here. And I'm ignoring the inner transition metals down here. They do fit right in here, remember, but I'll just draw this portion of the periodic table. And as you go to the left and down, so both of these things will be true, the ionization energy in general, but we'll talk about the first ionization energy. So ionization energy decreases. Ionization so as you go left and down, ionization energy decreases for both of those. Another trend is atomic size increases. And the third trend is that electronegativity decreases. Electronegativity, and my abbreviation, by the way, for electronegativity is going to be capital E, capital N. Electronegativity decreases. Okay. Anyway, so anything that you can memorize based on the shape of the periodic table is always useful. So whether you're online or eventually returning to face-to-face classes, so every chemistry exam I've ever taken, you had a periodic table available to you. So now to solve this, which atom has the greatest first ionization energy? Well, if ionization energy decreases this way, then ionization energy increases in just the opposite. We need the atom that is closest to the top right portion of the periodic table. Then I take my periodic table and I have, let's see, C, N, O, and S. Of these elements, the closest to the top right is actually O. O is going to have the greatest first ionization energy of these four elements. And you can see that looking at these elements, so fluorine has probably one of the highest first ionization energies. We tend to typically leave the noble gases out of these trends because they don't really bond, and we're using this for bonding purposes. So actually, I'd have to think about what happens for the noble gases. The noble gases get a little complicated for a couple reasons, but anyway, so if you have fluorine, it has the highest ionization energy of any of these elements to the left and down. If you have oxygen and chlorine, and the question was which of these has a higher ionization energy, it would be unclear because they're both lower than fluorine, but we don't necessarily know which one is, since they're diagonal, then this way. On the other hand, if it was fluorine and sulfur, fluorine is larger than oxygen, and oxygen is larger than sulfur, so we have a direct relationship there. Anyway, so there are the trends, you'll always have things that are more to the left and down if you're asking for smaller ionization energy, and just the opposite in this example. Any questions about this one? Okay.